Now, measurement of variables, operational definition and scales. Operational definitions. An essential component of an operational definition is measurement. A simple and accurate definition of measurement is the assignment of numbers to a variable in which we are interested. These numbers will provide the raw material for our statistical analysis. Measurement is so common and taken for granted that we seldom ask why we measure things or worry about the different forms that measurements may take. It is often not sufficient to describe a runner as fast, a basketball player as tall, a wrestler as strong, or a baseball hitter as good. If coaches recruited potential team member on the basis of these imprecise words, they would have difficulty holding down the job. So coaches want to know how fast the runner runs the 100-yard dash or the mile. They also want to know how tall the basketball player is, the strength of the wrestler, the batting average of the hitter. So measurement is a way of refining our ordinary observation so that we can assign numerical value to our observation. It allows us to go beyond simply describing the presence or absence of an event or thing to specify how much, how long, or how intense it is. With measurement, our observations become more accurate and more reliable. Next is precision, which is important in all areas of our lives, especially in science and technologies. As we look for ways of increasing it, here are interesting classroom demonstration for the precision of numbers versus the precision of words. Basically, ask the class members to write down a piece of paper of what the number word several represents to them. Then gather responses and then plot them on the board. You will be surprised at the wide range of numbers represented by the word. It usually ranges from 2 to 7. So, how often have you been in an argument with a friend only to find out after much debate that you are using keywords in different ways? The argument is one of semantics rather than of issue. You define the word one way and your friend defined it a different way. So this experience is more common among laypersons than among scientists, but it still occurs before the merits of an issue or proposition can be discussed. There must be agreement about meaning of the important terms. The same is true in science. If we are to avoid confusion and misinterpretation, we must be able to communicate unambiguously the meaning of such terms as intelligence, anxiety, altruism, hostility, love, alienation, aggression, guilt, reinforcement, frustration, memory, and information. These terms have been used scientifically in very precise way. Each of these terms could be given in a dictionary different definition, usually referred to as literally or conceptual definition, but dictionary definitions are not sufficiently precise for many scientific terms because they are too general and often too ambiguous. When a word is to be used scientifically or technically, its precise meaning must be conveyed. It must be clear and unambiguous. We achieve this clarity of meaning by operationally defining the term. To state the operations for a term means to make them observable by pointing to how it is measured. An operational definition then makes the concept observable by stating what the scientist does to measure it. For example, anxiety could be defined in a dictionary term as a stage of being uneasy, apprehensive, or worried. An operational definition of the term could include observable measures such as sweating palms, observable a sweat gland activity, increased heart rate, observable with heart rate recording, dilated pupils, and other observable psychological changes or physiological changes. It could be as a self-rating scale or Pepperant pencil questionnaire. We could in each case specify the precise amounts of each measure necessary for our operational definition of anxiety. As another example, consider the hypothesis that we proposed in the earlier explanation We hypothesize that the effect of TV violence on older children's aggressive behavior at school will be less if the characters are not human. Although this appears to be a clear statement, more specific operational definitions would be necessary before any research could be undertaken to test the hypothesis. The researcher must make several decisions what is violence on TV. Certainly, one character killing another character would be considered violence. What above a shove or push? What about a verbal assault? What about when there is some situation that falls off the cliff and is hit in the head with a rock? What constitutes a character that is not human? We could probably argue what fits the category. What about the computer animated person? How will aggressive behavior at school be defined? Of course, getting into fight would be aggressive behavior. What about profanity directed towards another student and teacher? However, the researcher must decide what is going to be meant by each of the variables in a particular study and be able to communicate those operational definitions to those who will be consumers of the research finding.